Hello, my name is Jason from 11 Science, and today we're going to be talking about the pH scale and the difference between acids and bases. So, the pH scale, or the power of hydrogen scale, is a scale used to determine how acidic or basic an aqueous solution is. The neutral pH number is 7. It has the equal amount of concentration of the hydronium ions and the hydroxide. More hydroxide ions means the pH is bigger, which means the aqueous solution is more basic, while more hydronium ions means the pH is lower than 7 and is acidic. There are a lot of things to compare to, but today we're going to be comparing it between two aqueous solutions. This vinegar and soap. Soap and vinegar, a well-known acidic solution and basic solution, is here, and we're gonna see the differences between. Okay, the vinegar smells, and well, frankly, the soap actually doesn't, but they added like a fragrance to it, so to make it smell better. And now the texture of the solution. The vinegar is normal, actually. It's just like water, nothing really special to it. But the soap is slippery and soapy. I'd like to call it like that. Soapy and slippery. So acidic has no soapy textures, but basic solutions has soapy textures. And now the taste. Now, most of you know that vinegar is sour. That is because it is acidic. It's very sour, so we know that is acidic. So that was the acidic, the vinegar, which vinegars are usually at the scale between 2.5 to 3 pH in the pH scale. Alright, now the base. So, the soap, which is usually around 11 in the pH scale, is bitter. It tastes bitter. So yes, that is the difference between acids and bases. This one is sour, very sour. This one is bitter, very bitter. The vinegar is doesn't have a soapy texture, while the soap does have a soapy texture. The vinegar smells strong, while the soap does not does not have strong smell to it. And yes, those are the differences between acids and bases. In this diagram right here, we can see that the pH can be neutralized by other aqueous solutions. So, will the sourness of the vinegar be slightly reduced or even replaced by the bitterness of the soap? We're gonna try that out on this cup right here. We're give a hefty amount, yeah. That smells. And we give soap. Oh wow, that is right. Looks like they won't mix. That's hard to see here, but oh no, did I spill? Okay, I didn't. So I'm just gonna mix it right here and see if this will kill me or. Oh wow. Actually, it turned to something stranger. It's completely white. Meanwhile, both of these are colorless. The liquid that has been mixed here has become completely white. Now, taste test, right? Okay, that is actually surprising. Sorry. Sorry. That's actually surprising because when I mixed these two and tried it, it's not as sour as the vinegar by itself, and it's not as bitter as the actually the sourness of the vinegar has been reduced by the bitterness of the soap. So yes, the pH can be neutralized, and we have confirmed that. And if you want to turn your vinegar less sour, you can mix it with soap if you're willing to do that. But it still tastes horrible, and I do not recommend. Also, we haven't tried out the texture, right? There is no more soapy substance to it, despite it being soap. There is no soapy substance. So yes, it has gone either slightly or completely neutral. Maybe it's slightly neutral because I can still taste a lot of sour inside that. But yes, the pH can be neutralized. I will confirm that. Thank you for watching.